Hello and welcome back to Statistics. Now we're starting chapter 2. We are going to talk about organizing data. You already saw me write data earlier when I needed a sample of 15, and I put 3 rows of 5. So it's easy for me to see that it's 3 times 5, 15 data points, and I know where to stop my calculations and everything. Now we're going to devote the whole chapter on the way to represent and organize data so that we can do calculations later on. We're going to start by defining variables and understanding what the variables are in statistics. So this is a big definition. Let's go with the red. I never used this color. What is this color? It's okay. Let's use this one. I've never used this color. I don't even know what it is. It's not red, it's not pink, and it's not purple. And I only know 16 colors.
Magenta.
Magenta. I don't think I can spell that. They get it? Spelling bee?
Yes.
Perfect. I'm going to leave this in notes. All right, variables. All you need is 16 colors. So a variable is a characteristic that varies from one person or thing to another. Variable is a characteristic that varies from one person or thing to another. It's very easy to point those out: height, weight, age, color of the object. Let's say these desks are gray in the other room, and so on. So there are a lot of different things that you can also have as variables. Time, right? So all of that stuff. And now we have types to consider. So there's a qualitative variable. And that will be a non-numerically valued variable. Quantitative variable, a numerically valued variable, and you already suggested age, height, one more.
Shoe size.
Shoe size? Well, yeah. Good. What else? Discrete variable. All right, this is where the fun begins, with the discrete and continuous variables. So discrete variable would be a numerical variable where all of the numbers can be listed. Okay? Number of pets in a house. Amazing. Number of students in a classroom. And then you will have continuous variable where any number is okay. So we'll talk about these in detail. So a quantitative variable whose possible values can be listed. In particular, a quantitative variable with only a finite number of possible values as a discrete variable. So we have to be careful about that. So a quantitative variable whose possible values can be listed. Let's see examples. Number of pets in a house. Number of pets. Perfect. Number of pets in a house. Number of students. Because you have to register, right? And you can't have 0.5, 0.7, 0.38, right? So it's a whole unit. You can't go to the store and buy half of an egg. You might be able to convince someone to sell you one, but you can't definitely buy 0.38 of an egg. So certain things are quantized, which means, and discrete, which means there is a unit, and it goes in those units, and you can list those units. So number of pets in a house, number of students. What else you suggested? You had more.
Number of siblings.
Number of siblings? All right, what else?
Do you have a number of streetlights in a mile?
Yes, number of traffic lights, sure. Or street signs or whatever it is, yep. Number of street signs. But then I want to also pick from up above. Age, height, weight, shoe size. Nope. Discrete. See, the weight is tricky. Yeah, you have your bathroom scale. You know, you have your bathroom scale and you stand on it, shows 283, right? And you look at, well, that's me holding the dog. So, yeah, the scale is just not precise. Scale is not precise. You see, it's not that you have a meal and your weight clicks from, I don't know, 134 to 135. On a scale, it might look like that because the scale is not precise, but that weight gradually, right, happens. It's not an instant click. And you can be 135.7, 135.73, 135. So you go to chemistry lab, it has number of decimals that it will, you know, for the precision. So weight is not going to be discrete. The weight is actually continuous, which is the next. Age. Well, generally the way we look at age, right? You're either 21 or 22 or 23. No one really goes around and says, oh yeah, I'm 21.7. And then you wait a few seconds and now you're 0.8, right? So yeah, sure, as the convention, yeah, we can take a look at age and say age would be discrete because you're either 21 or you're 22 or you're 23 or you're 24 and so on. However, height and the weight, you're tallest when you wake up in the morning, and then you get shorter and shorter throughout the day, and then eventually you pass out, and then you are tall again. So the joints, when you are horizontal, right, the joints spread out as you relax. So you stand up tallest for the day when you get up. And then the weight of your body will be compressing those joints ever so slightly. We're talking about fractions of an inch, guys, but still, fraction of an inch, right, is that little. And then you also look at a child, right? You know when you heard this million, oh, you grow. Yes, because you looked at it as a discrete, right? Whoever saw that kid, right, a year ago and then the next year, of course, right? But you didn't notice that because you are looking at that particular thing every day. As it grows. This way as well. So we have discrete variable, and we can definitely add to this discrete one age and shoe size. That's okay to add here. But we are not going to add the weight and the height because those are the ones that are in continuous. So a continuous variable.
I have a question.
Yes.
So you said you can include shoe size in the discrete variable?
Yes. Can you find a shoe that is
That's because they only come in half sizes, so you know that.
Exactly. Yes. I don't care what the denomination is. Also money. Think about it, right? $19.99, right? And if you really want to dig deeper and be picky about it, you will go to the gas station and you're going to see 2.43 and then 9/10. But you will never see a smaller denomination for money other than that third decimal that you don't see anywhere else except for the gas prices, right? So money is definitely discrete because it is increments in cents. And then if you really want to be picky, well, sure, we can extend that to the only two, right, examples that we know and have would be the gas stations and office space. Other than that, there are no other smaller denomination of a cent, right? They were stealing in that movie. Right?
Money as like the 1 cent as like 1 unit. So if you have a dollar, you have 100 units.
Yes.
Right? Okay.
Yes. Oh, you know the movie?
Yeah, I know.
It took time to click in, right? Well, that's the part they were stealing, because no one checks that. When you round it off.
I just went there rather easily, that's all I'm saying.
Yeah, but
That
see,
example was like that, the way you just went to it.
all of the things are always available to me. I just choose to censor them or not. That's the part. Sometimes filter doesn't hit in quickly enough. So, we were talking about continuous variables. All right. So far, I have A. A quantitative variable whose possible values a quantitative variable whose possible values form some interval of numbers, which means you can't list all of them. There are infinitely many. Quantitative variable whose possible values form some interval of numbers. At seconds. But see, every time you're doing that, it's discrete, discrete, discrete. And then you have a milliseconds and nanoseconds and picoseconds, right? And it keeps fragmenting like that. So for our sciences, let's say, in some cases, you have to go to extremely small intervals of time. You want to show special theory of relativity or something like that, prove the time travel and all of these kind of things, which are actually done. These are all very short intervals of time measured by atomic clocks, which are very, very precise. The question is how far we can fragment the time. Is it a continuous variable? We know that you are, and me and everyone is growing height-wise and weight-wise continuously. You don't go from 7 pounds to 8 pounds to 9 pounds because you go and you hit every single infinitely divisible marker along the way. And that's what the continuous variables are. So, yes, we are in our speech, we're just going to round to the closest, or our inaccurate, or imprecise, actually, imprecise bathroom scales will give us a number, right, that we might not have enough precision to go dig deeper and see all the way down to infinity what it actually is. Network exploded, great, connect, and there we go. I'm going to say time, I'm going to say weight, I'm going to say height, but you know what, I'm going to go to the upper and put dates for discrete. Would you all agree that Monday just switches to Tuesday, right? And I don't know, February 17th just turns to February 18th. There's no February 17.8, right? So you see that discrete, again, think of discrete units, and your question about, you know, half a shoe size is great, because it doesn't have to be one whole unit. You can be discrete, and we talked about shoe size, discrete by halves, and then your money being discrete by cents, and if you want to be picky, 1/10 of a cent, which is still okay, but there's no smaller denomination than that. Now, in your weight, you can measure yourself in kilograms. I'm not going to go to pounds because the units don't work well as well. So you go into kilogram, and then smaller unit than kilogram, 1,000 times is gram, but then you have a milligram and microgram and nanogram and picogram and attogram, right? Each time is divide by 10, divide by 10, divide by 10. And how far can you go, right? Well, obviously the size of atomic particles, why can't the -15? But again, conceptually, you can go forever. So continuous, right? It has to be continuous. It hits all the markers. It's not 7 pounds, 8 pounds, it has to hit every single one in between to go from 7 to 8. So I hope that the story of these things makes sense. And there's an excellent graphic in a book which really nicely summarizes these definitions. It says variable is split into qualitative and quantitative, and then quantitative are split into discrete and continuous. And that's the tree they give you in the book. It's really nice summary. So variable is a characteristic that varies from one person or thing to another, and then you have definitions for all 4 of these. So age is a variable, but if you tell me that you are 21 years old, I'm going to say variable is age, but you're telling me 21, that's data. So if I go around a classroom and I select 10 random students and ask for the age, I will collect data. So variable will be age, and the numerical value of the variable is called data. So here is another definition. This section is just definition, definition, definition. You are learning words. So data is values of A variable. Values of a variable. And I want to just make a little chart over here. This is my example. So variable, data. So you can separate these mentally. Age, and over here I'm going to say 21, 22, I don't know, 37, 54, right? So numerical values of age, or, I don't know, wait. 138 pounds, 127 pounds, 149 pounds, 270, 27 pounds, that's it. I don't know, it doesn't matter, whatever. And just go through these. Qualitative data, quantitative data, discrete data, continuous data, you just connect them to their respective variables, okay? I'm just going to go with the qualitative data definition.
So why is the variable is going to like qualitative, so data can be qualitative or quantitative?
Yes. It's just what it belongs to, because it's a one-to-one correspondence. So you have a, we talked about eye color, right? And then you have all different colors of eyes. So when you say eye color, that's a variable. It's a qualitative variable. But when you actually list the colors, so we go one by one and look into each eye, right? And take a look at the color, then that's data.
So the data would be blue, green.
Yes, very good. Mm-hmm. And then I'll just put 3 dots for all of the same, the ones. Each individual piece of data is called an observation. Ooh, what's this? I'm going to leave this one. Really? They have this stuff? Someone actually thought of that and sat down and programmed it, okay? I'm switching to this. Guys, I've been using this software for 3 years, which is the full version of the software, and they don't have these things. I get this is the enterprise, part. And probably this is the fun one. So I'm happy that I switched. It's called an observation. I'm using this software for the first time, this version of OneNote, for the first time ever. As you can see, everything is blank. I did testing. I tested it yesterday. This is me testing it yesterday. That's it. I know. Oh yeah, I really wrote la la la. It's fun. Anyway, they have this stuff. I'm amazed. Is there anything else that we need to talk about? Because that's variables and data, and that's the title. The rest is example 1, 2, 3, and 4, and then homework examples. Nice. Wow, no death. IPOs, earnings, highest temperatures. Oh, there is death there. Earthquakes. Yep. University rankings, industry statistic, Fulbright program, IBI Kings. Okay, good. They're kind of moving away from death and destruction, other than one example, which is nice. The book is evolving. Okay, so let's go and take a look at problem 2.8. If I hit your homework example, then you guys just pick something else. This is a top 10 IPOs. IPO is the initial public offerings, which is actually when the company goes public and goes from being just a private company into having the stocks and those things, and then you have the shareholders and you have the meetings and other things coming up. So, and people are smiling and laughing because they know. All right, so here's the chart. The first one is the rank. Second one is company. And the last one is the IPO in billions. So number one is Visa with 17.86 billion. Number two, now with 1645. Number three, Facebook with 1600. Number four, General Motors with 1577. Number five, Deutsche Telekom. I don't speak German. On 13. Number 6, AT&T. Wireless, 1062. Number 7, do I really have to list all 10? Kraft Foods. At 868. France Telecom, Telstra, and Swisscom. That's fine. That's just 7. Top 7 IPOs. I'm here. Problem fixed. Yeah, I'm changing it to top 7. There are also France Telecom, Telstra, and Swisscom, and spots 8, 9, and 10 is completely irrelevant. So part A. What type of data is presented in the first column of the table? Uh-huh. I abbreviate the question. And you all said what? Discrete. There is no 1.1738 on it. It's just 1 and then 2 and then 3. So discrete, and it's ranking. So we understand that. Good. B, what type of data in the second column? Very good. Qualitative data. So we have, oh, actually, we should say discrete, comma, quantitative, right? So both of those. And then the second column, you already said, it's qualitative. And then we have number 3, part C. And it says what type of data is presented in the third column of the table? Should we do the continuous or should we do discrete? Yeah, money. It goes into bundles. You can go down to cents. And also in a billion, you have 1.2 billion, 1.3 billion, but you can't have 1 point and put 10 decimals on it. I would highly disagree if this, if anyone has the book, and if there is answer to this question in the back, if they put continuous, I'd be really upset. So quantitative, discrete. And part D, what type of data is provided by the information that the Facebook is a social networking business? What type of data is provided by the information that the Facebook is a social networking business? Yeah, it is. What did you say? Qualitative, yes. Oh, you said qualitative? Okay. And it's a single, so it's observation, right? So part D, type of data Facebook is a social networking business. Answer would be qualitative. And you can also toss in observation because it is a single data point singled out of the other 7, right? Each company does something else. And Facebook is the social. No? Discrete is only for quantitative, right? Discrete has to be a number. If you look at the discrete, it's also the number, the words, the descriptions. All right. Well, that's 2.1. So next class, see ya.